Hello, grade 8 learner. Welcome again to another mathematics lesson. In this video lesson, we will discuss how to prove that two triangles are congruent, which is based on the K-12 curriculum learning competency. The learner proves that two triangles are congruent. It's another great day to learn, so grab your pen, paper, and module as you start watching and learning from this video lesson. Refer to your Quarter 3 Math module entitled Proving Congruent Triangles for this example. Let us prove that the two given triangles are congruent through a triangle congruence postulate or theorem. We begin by observing the figure. Given the two triangles, let us mark the parts that are given. Since side AD in triangle CDA is congruent to side BD in triangle CDB, we draw the same hash marks through the sides. Since angles CDA and CDB are said to be right angles, we draw the symbol for right angles, which is a small box, where the angles are. After marking the given parts on the figure, let us also identify the triangles to be proven congruent. We have triangle CDA here and triangle CDB here. Notice the marked parts on each triangle. Let us process what we know. Let us recall the triangle congruence postulates and theorems discussed in your modules. Let's start with the SAS, SSS, and ASA postulates. Note the parts of the triangles that should be proven congruent. So, for SAS postulate, we need to prove that a side, an included angle, and another side are corresponding and congruent in both triangles. For SSS postulate, all three sides have to be proven congruent in both triangles. Finally, for the ASA postulate, we need to prove that an angle, an included side, and another angle are corresponding and congruent in both triangles. Next, we review the right triangle theorems discussed in this module. Given that the triangles to be proven are right triangles, we use the LL, LA, high L, and high A theorems. Take note once again of the parts that need to be proven congruent for each theorem. To prove that the triangles are congruent through the LL theorem, we have to prove that both legs of the right triangles are congruent to each other. We use the LA theorem when a leg and an acute angle of the right triangles are congruent to each other. For the high L theorem, we prove that the hypotenuse and a leg of the right triangles are congruent to each other. Finally, for the high A theorem, we prove that the hypotenuse and an acute angle of the right triangles are congruent to each other. Now that we've reviewed the congruence postulates and the theorems that we can use to prove that the triangles are congruent, we then ask, Which postulate or theorem will best be used to prove the congruence of the triangles? To help you choose, look at what is given in the problem. Let us solve. We write our statements that prove that the triangles CDA and CDB are congruent to each other. We begin with the given, which is side AD is congruent to side BD. We mark them with similar hash marks. Another statement was given that angles CDA and CDB are right angles. We draw the symbol for right angles where angles CDA and CDB are. From here, we now make statements based on the given information. Since both angles CDA and CDB are right angles, that means they both measure 90 degrees. That implies that angle CDA is congruent to angle CDB since all right angles have the same measure or are congruent to each other. Another statement that we can make is based on our observation of the figure that's given. We see that side CD is common to both triangles CDA and CDB, which implies that side CD is congruent to side CD through the reflexive property. This simply means that side CD is congruent to itself. Studying the statements we made, we have proven a pair of sides, a pair of angles, and another pair of sides that are congruent to each other. Take note also that the angles are included in the identified sides. Thus, we can now say that triangle CDA is congruent to triangle CDB by the SAS postulate. We now state our conclusion. We were given this problem to solve. Through the given and our deductions from the given information, and by marking congruent parts on the figure, we have proven that triangle CDA and triangle CDB are congruent to each other by the SAS postulate. An alternate solution to the problem uses a right triangle theorem to prove the congruence of the two triangles. Our proof still begins with our given, that side AD is congruent to side BD, and that angles CDA and CDB are right angles. For our third statement, we will make a statement based on the previous statements. Because angles CDA and CDB are right angles in the triangles, we then say that triangles CDA and CDB are right triangles. This means that we can also use a right triangle theorem to prove that the triangles are congruent. After proving side CD is congruent to itself by reflexive property, we then check which parts of the right triangle are proven congruent. We see that we have two legs that are proven congruent. Thus, we can prove that triangles CDA and CDB are congruent by the LL theorem. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.